Video, I'm going to demonstrate how to simplify fractions. The direction simplifying fractions means that we want the fraction to be in, there's a lot of different terminology that you can use, like lowest form, simplest form. So just be aware that terminology might be interchangeable. There's a couple different ways that we can actually refer to this as in simplest form or lowest form. So here we go, simplifying fractions. So what I'm going to do is, for this first one at least, I'm going to walk you through the process of simplifying 6 over 10. The concept here, like here's what we're trying to get done in general, is we want to write this number in a form where there is no other numbers that can go into it. For example, I'll just do it underneath here and I'll erase it. Like 1/2. 1/2 is fully simplified, because I don't have any number that goes into 1 and 2 that can be a multiple. Like if I had 2 over 4, let's say. 2 over 4 can be simplified down to 1/2, because 2 goes into 2, because 2 times 1. 2 goes into 4, because 2 times 2. So then I would divide each term by that 2. And I'll walk you through this process, but I just want to show you the difference of what it means to be simplified and not simplified. So now let's actually go through the process of how we simplify this and that actual behind the scenes that goes into it. So 6 over 10. Here's like the long form, and as I go through this video, I'm gonna just speed it up a little bit, but for this first one, I want to break down the exact process of simplifying this fraction. So for 6, I want to think about all the numbers that multiply to 6. So 1 times 6, 2 is 2 times 3, 3 is 3 times 2, and then 6, because 6 times 1. All right, let's do 10 now. 1 times 10, 2 times 5, 5 times 2, and then 10 times 1. So what we're trying to figure out is, what is the largest number that goes into both 6 and 10? So meaning the largest number, the greatest common factor, if you want to use specific terminology, what is the greatest common factor, the largest multiple that goes into 6 and 10? And that would be 2. They both have 2 in common. There is no number larger than 2 that they both have in common. So since that's the case, what I'm going to do is I'm going to do 6 divided by 2, and I'm going to do 10 divided by 2. So I'm going to divide both the top and the bottom by 2, that greatest common factor. 6 divided by 2 is 3. 10 divided by 2 is 5. So simplest form would be 3 over 5 from 6 over 10. So 6 over 10 simplifies down to 3 over 5 because 2 goes into 6, 2 goes into 10. There's no other larger number. Let's take a look at 10 over 15. And as you go through this, like what the whole goal here is, you don't want to have to write down every single number that multiplies, because if you look just ahead a little bit to number 6 down here, look at that, 100 over 300. Like, you could waste a lot of time. So I'm going to talk about just the thinking process that you want to take on. So 10 over 15. So let's just talk about that thinking process. So first of all, like looking at the number 10, we know 10 goes into 10. But 10 doesn't go into 15, meaning like 10 times 1 is 10. 10 times 2 is 20. 10 times nothing, clean numbers at least, will give us 15. So I don't want to use simplifying by 10. So let's think about, well, what are some numbers that go into 10 and 15? 5. 5 goes into 10. 5 goes into 15. And if you're like, well, I'm really not sure. There's always like a trick to divide by 2. Like on number 1, I could have divided the 6 and the 10 by 2 and then seen what that fraction might look like. Like on number 3, I might want to use that trick, like we'll see. But here, 2 is not going to work on number 2, because if I divide by 10 divided by 2 works, but 15 divided by 2 doesn't. But we got, like we talked about just now, 5 does. So I'm going to do 10 divided by 5, 15 divided by 5. 10 divided by 5 is 2. 15 divided by 5 is 3. So 10 over 15 simplifies down to 2/3. Let's take a look at number 3. Now, in some cases, writing out the multiples might take a while, like I was showing you on number 6. We might not want to write down all the multiples and everything that goes into it. So we want to just think about just both the numbers. Like, think about conceptually, like, what's happening with 44. Like, what are some potential numbers with 44? So, like, looking at 44, that's 4 and 11. I know 44 is 4 times 11. So that tells me, like, okay, well, does 11 work into 24, or does 4 work into 24? And then I'll go from there. Like, don't always just try to say 24 is 1, and then, like, 2 times 12, and then 3 times 8, and so on. Like, that just, you're going to waste a lot of time, and you're not really, like, gaining any skills in simplifying these quickly doing that. So I'm looking at 44, and I'm saying, well, 44 is 4 times 11, so I'm going to try to see if I can work with that 4, or even the 11. So 11, no, 11 doesn't go into 24. 11 goes into 22, but that's not 24, so no, 11's out. But let's, what about this 4? 4 goes into 24. Nice. So then, that tells me I'm going to divide both the top and the bottom by 4. 24 divided by 4 is 6. 44 divided by 4 is 11. So 24 over 44 simplifies down to 6 over 11. And I know it's in simplest form because I can't go any further. Let's just pretend, just make believe here. Let's say I ended up with like 6 over 12 by dividing by 4 or whatever. And it was just a different problem. So I got 6 over 12. 6 over 12 would then be simplified more because 6 goes into 6, 6 goes into 12. So I'd be able to simplify that more down to 1/2. But in this specific problem that I just did, I get 6 over 11. 6 is 3 and 2 and 6. 11 is just 11 and 1. So there's no common ground there. So 6 over 11. Try to keep these on my screen as I go through these last couple. I'll just move this up a little bit. All right. Number 4, 18 over 42. So 18 over 42, think about the numbers again. Like, right now, I'm kind of having like a moment of like, you know what, I'm not like super sure. So here's what I would do. If I'm in the situation of like 18 and 42, I don't want to write down every single number that goes into them. And I'm just like, I'm having a little bit of a block. Like, I'm not quite sure. What I do know right now is that 2 goes into 18 and 2 goes into 42. Because they're both even numbers. So if you don't want to sit here and like, maybe 4? Does 4 go? No, 4 doesn't go to 18, but just don't waste a whole bunch of time. Divide them by 2. So here's what I'm going to do. I know, again, I could divide by 2 because they're both even. So I'm going to divide by 2. And then we'll see what happens. So 18 divided by 2 is 9. 42 divided by 2 is 21, right? 21 times 2, yep, 42, okay. So 921. And then we just reset the table. Like, we're like, okay, well, here's a new problem, 9 over 21. And if I'm asked to simplify this problem, can I simplify 9 over 21? Now the number's a little bit more manageable. 9 and 21, we can hopefully see that, well, 3 goes into 9, 3 goes into 21. All right, now I'm gonna divide by 3 now. So now I'm going to divide both the top and bottom by 3. 9 divided by 3 is 3. 21 divided by 3 is 7. Then I get 3 over 7. Nothing else can simplify there, so I'm done. So that's a little bit of a longer route, but I think in terms of your time commitment, I think this might actually work out better for some, just because you're like not sitting here thinking about, well, 2 goes in 18, 2 goes in 42. What about 4? No, 4 doesn't work. What about, like, I don't know, 12? Does 12 work? 8? Does 18 even work? Like, you know, you're sitting there just messing around with numbers, and then you're writing down the multiples. So just dividing by 2, because they're both even, makes it a little bit more manageable right there. So what we would have divided by is 6. Would have been the largest factor that goes in both 18 and 42 would have been 6. Anyway, doesn't matter. Let's go on to number 5. So 50 over 65. I'm going to use the same kind of trick. So 50 and 65. I know 50 doesn't go into 65. I know 10 doesn't go into 65. I'm noticing 5. 15 is a tricky one because, like, you think, oh, 50 plus 15 is 65. Like, maybe 15's work. But let's just go by 5. Let's see what happens. Divide by 5. 50 divided by 5 is 10. And then 65 divided by 5 is 13. So then I get 10 over 13. And that's done. Can't do anything with that. And the last one I want to show you for simplifying fractions is number 6, 100 over 300. This is a type of simplifying fraction that people can waste a lot of time on. Like you think, oh, 100, I gotta divide by 10 or 5. Like what? Look at this, 100 and 300. 100 goes into 100, 100 goes into 300. Done. Divide them both by 100. 100 divided by 100 is 1. 300 divided by 100 is 3. 1/3, just like that. So don't waste so much time. Like, think about just the logic behind it and think about, well, 100 actually goes into 300 and 100 goes into 100. Cool. Like that's a lot of time saved. Just like on number 4, showed you that little trick of see even, divide by 2. And then here, a little trick of this number actually goes into that number. So we could simplify pretty quickly there. All right, so this video was about simplifying fractions. And then from here, you can do a lot with fractions. After you know how to simplify the fractions, you can do a lot more. So hopefully this helps you out with simplifying fractions.